Okay, this is the practical video on how to do Lab 2. So what you want to do is you want to go to the Canvas files under Lab2Help. Okay, so we're under Lab2Help, Lab 2. Okay, now not all the files are here yet. Now what you want is Lab2Zip. Okay, you want to actually download it. Okay. You want to download it to the desktop. I already have it there. Okay, once you get it on the desktop, here it is, see? So that is your source. Now, you're not going to create your own projects anymore. Okay, you're not going to run the wizard to set up a project anymore because there's too many mistakes happen and the students have to start their labs over because of the mistakes they made, okay? So typically, they don't specify a file folder, so their files are all over the drive instead of a file folder, and they even lose their work because they can't find it. Okay, the other thing is they don't specify a simulator. They don't specify the Altera model sim simulator, or they make a mistake and specify the Verilog language instead of VHDL. Okay, so if they make the mistake and they don't specify what did I say it was? The Altera model sim. When it's gonna gets close to simulation, okay, and when it's trying to make a test bench, it can't make a test bench because it doesn't know what simulator to make the test bench for, and it doesn't know what language to make the test bench in unless it's specified language is VHD. All right, so we in the past we had countless errors with this, nobody getting anywhere. So what I do now is I provide you with a zip file, and you unzip it in your place where you're going to work. Okay, so you're going to work in C, Intel FPGA Lite 18.1. Oh, it's already there for me because I did this already. Okay, so what you got to do is you have your destination here and your source there. You double click this, open it up, what's inside? What's inside the Lab2 zip is the uncompressed Lab2. So you click on it, hold down with your left finger and drag it into the source. Drag the source into the destination. Now there it is. Now close this, open this. Now, do not think you can shortcut this. You have to actually drag it. Some students think that they're just going to double click this, okay? They think they're just going to double click this and it'll work. Okay, what happened then is they won't be working in Intel FPGA Lite. They will be working in the app data folder, which is a hidden folder used to store browser download files. And then they end up losing their work because they can't find it. It's a hidden file. Okay? So don't shortcut this. Okay? Don't shortcut this. So there we got it. So back up. What would you do? Yeah, we got this Lab2 copied over in the destination. So do this in the destination, not the source. Double click it. What's in there? Okay, Lab2 QPF, that's a Quartus project file. We can open the project by double-clicking this, or we can open it by opening this and have this open this QPF. Okay, but for now, we'll just do this. Double-click the Lab2 QPF. Okay, so it's open now. Now, the first thing you have to do is this. Where it says hierarchy, right? You see where something changed? Change to the files. Don't leave it hierarchy. Students want to leave it hierarchy, and they wonder why it doesn't work. Okay, you got to pay attention to this. So, at the point where you're going to go to simulation, you have to have two files in here. One is lab2.vhd, which is your design code, and lab2vhd, same name but in a different subfolder under simulation molecule sim. Okay, and you don't want lab2vhd and lab2bdf. If you get lab2bdf in here, you have to right click on it and remove it. Yeah, remove it. Okay. Okay, so students want to leave this out. They say, well, that doesn't matter. No. When it goes to synthesize, remember synthesize? It looks at the files in here. Okay? If they're not there, it's going to be a problem. Okay, so what you're going to do now is start drawing the schematic. So file new. Block diagram schematic file. Okay, what's the name of block 1? That's not a good name. So go save as lab2bdf. Now, here, uncheck add current file project. Okay, I'm going to do the mistake that you're likely going to make. Okay, so now it's called lab2bdf. It has to be called lab2bdf because the name of the project is lab2bdf, and that establishes it as top-level entity. If it has any other name, it's not top-level entity. It needs to know what top-level entity is because it will create the test bench for the top-level entity. Okay, now, lab2bdf got in here. You're not supposed to have BDF in this files list. So right-click, remove it. Okay, now, you got lab2bdf. Yeah, so that's going to work. It's saved under that name. So now we're going to start drawing. Okay, is anybody hearing me? Yeah, okay. So you are going to go to input markers. You're going to need, let me see, 1, 2, 3, 4 of them. Okay, now you're going to need inverters. So type not. Now, what you're going to do is stick it on here. 1, 2, 3, 4. Now, there's a little problem here. I'll show you. You have to have a piece of line between this pin marker and this. So you got to use right arrow key to move it a little bit, and then you got a piece of line. Okay, you see that? So I use right arrow key on the keyboard to nudge it. Okay, is that enough? Oh, I know, they're not lined up. All right, so go here. Nudge it. Actually, the smallest bit of wire is enough. Okay, now what's going on? Can zoom out. Okay, and line them up. Right now, I got to. Okay, I have to have wires here. Okay, what am I doing? Well, look at this. See this PowerPoint? That shows me that I can create this by having the unsimplified circuit drawn near the top of the schematic and the simplified below. And they have to have different output markers, differently named output markers. Otherwise, you're shorting the outputs together, which is a disaster, okay? And then for convenience, so you don't have to draw inverters in this circuitry, you can put an inverter on the input marker and name the output of the inverter. So everywhere you need, for example, A primed in a circuit, you put AP. So see here where we've got D underscore P, that's because we need D primed there. So this connects to the output side of the inverter, and it gets the inverted D, which is D primed. Okay, you see that? Oh, okay. Now, and this is your 16 variable test bench you're going to need. Okay, yeah, test bench process you're going to need in your test bench template. Okay, so how long is the total time? Well, there's 16 times 50. How much is that? 800. Okay, now you see what I did? I set A equals 0. Once A is set to 0, it doesn't change until you change it. So for all these other lines here, A is 0 until I change it to A equals 1. Then it's 1 for all these lines. Okay? Now if you look at a truth table, the very left row for A will be half zeros and half ones. Okay, so that saves me writing on every line A equals 0 repeatedly. Okay, so you have these two slides for your practical slides. So I need to do that. So go back to here. All right, so I got this one. Going to be named A. This one. Going to be named B. Okay. And this one. Going to be named C. Okay. This one. Going to be named D. Okay. Now I need A primed. So I go A underscore P. B underscore P. C underscore P. D underscore P. Is that correct? A prime, C, B prime, C prime, D prime. Okay, now, something else I got to do. Move these as close together as possible. Okay, now, save it. Now, the name it has is Lab2PDF. If it didn't have that name, you would have to go File, Save As, and save it as Lab2PDF. The name has to be Lab2PDF because the name of the project is Lab2. So if this is Lab2, the VHDL code will create the entity name Lab2, which will match the Lab2 project name and make Lab2 the top level entity. All right? Actually, the other way to get top level entity is to right click on the file and set the top level entity. So the design file at least. Now, gotta start drawing this. Okay, I need to do a save so I don't lose any work. So I gotta start drawing this. All right. So I want to get this green lettering here. So what I'm going to do is I'm going to go to my lab report right up, and I'm going to copy all this. Okay, so Control C. Now I'm going to go here to this A, capital A lettering tool, and then Control V. All right. Yeah, so keep clicking around. Now you see where it says question mark? Question mark is going to be your complement. You could change it to complement. Let me see. Or leave it. Then you'll know that question mark means complement. In this at least. Okay, so now we got that. Now go back to the arrow tool. Now take this and move it up. Okay, now this is not executable. It does not have any effect on the way things run. All it is a comment for us to be able to remember what our equation is. That's all it's for. Okay, so go back to the arrow tool so it can place things. So we have to draw according to this equation. Okay, so first we're going to need a 3-input AND gate. Here it comes. Okay, then we're going to need a 2-input AND gate. Okay, 3 input and 2 input. Okay, then what? Well, they're called BCD or CD. So do that now. Put the lines on. Okay, now I see this line. I'm going to grab it and hold my left finger down on the mouse and drag it upward. That's called rubber banding. If rubber banding is turned on up here, you see where I'm pointing? You can do rubber banding. And you can drag and move. Okay? So this is B, CD, C, D, BCD. Got BCD. And then CD. C. And then D. D. Okay, now what? BCD, or you got to be OR together. Okay, so I need an OR gate. OR2. Okay, so put it there. Now OR them together. Okay, drag it down, stop. Drag it, stop. Now, drag it, stop. From here, drag, stop. Now, a common error that students make is they get what are called tumors on here, okay? So that means they get, I don't know how to do it. The closest I can come is this. See? So it looks like that. Where where two wires meet, you don't have that. That happens when 3 or more wires meet. Okay, so somehow by drawing with an unsteady hand, they get this kind of a tumor where there's no need for a junction because you don't have 3 or more wires meeting. So if that happens to you, you got to remove it and redraw it. Okay, now a common mistake is don't connect. You see it's not connected? See how it ends it with an X? So when you go to generate the VHDL code from this, there's going to be an error or a warning, okay? Probably only going to give a warning. And then it's not going to work. So you see this line terminated in X. You got to join it, okay? So don't have any unjoined wires. Okay, now this whole thing got to be ANDed with A. So I need an AND gate. AND 2. I'm going to stick it on here. Then I'm going to use my right arrow key to drag it out because I need a piece of wire, okay? Then I'm going to do this. So I have to AND with that A. Okay, so I got this part done already. I got 1, 2, 3 terms to OR together with a 3 input OR gate. I'm going to take this. I can move it in to make it more compact. You see? So one term is done. Now notice these two terms are almost identical. So I'm going to do a trick here. So I need 3 2-input gates. So here comes. And 2. Now I'll use repeat mode. So I need 1, 2, 3. 3 of them. Okay, now produce wires. Okay, what I gotta do? I got to OR the three together. And then I got to end with A. So go here. OR 2. No. I could have used this undo arrow. You see this? If I would have put it down and left it, I could have used this undo arrow. Okay? So what I need is 3 input OR 3. Okay, type it correctly. OR 3. So here comes OR 3, and I'm going to stick it on there. Now I'm going to right arrow key, move it. Okay, now I'm going to patch in the other lines. Go to about there. Okay, let me see if I can close it up. Left arrow key to compact it, okay? Now, what I got drawn? I got to end that with A. So I need and 2. So stick it on there. Escape. Now, right arrow key. Give a piece of wire. All right, now go here. Go here. Go here. Okay, so that's going to, okay, well, don't label it yet. Okay, now you see this structure? That is for this. But this has exactly the same structure, just different variable names. So I need to take this and copy and paste it. All right? Now, I need more space at the bottom. So, let me see. To get more space at the bottom, I'm going to just take any old gate, stick it there, then escape. Then I'm going to go like this, drag it downward. And then I'm going to delete it with delete key. So I made more space down here. Okay, so what I'm going to do is zoom out. Take, no, not all of this. No, only this. Go Control C to copy. Then go down here and click right click, paste. Now use the arrow key on the keyboard, up arrow and left arrow to move it in place. Okay? So now that I got that done, I just label everything. Just label everything. Okay, so this is going to be BD primed. B. And then this is D primed. So D underscore P. Then what? BC. B. C. Now what? CD. C. D. Okay. Now that gets ended with A right here. Now this one is going to be CD primed or AD or AC. C. D primed. CD primed and what? Or AD. Next one's AD. AD. What's the next one? AC. CD primed or AD or AC. Right click properties. A. C. C. Okay, so we got CD primed or AD or AC. Okay, now what? This goes with A primed. Okay, so notice I got three things here. This one don't have a wire. No, I can't have a touch in there. It's no good. Okay, so these three things got to get ORed together. Well, I know my problem. Yeah, so move it in like that. But you don't want to have it touching the box. So we got three wires looking to connect up to something. So those three major terms got to be ORed together with a 3-input OR. So go OR3. Now stick it on the middle one. Okay, try again. Stick it on the middle one. Now highlight it and drag it right. Okay, like there. Now hook up the, okay, how much? Okay, can I hook up the other wires or not? Okay, I can grab this wire, put it back there. Okay, so I got 1, 2, got 3 of them hooked up. Yeah, drag against the line up, okay? So look, zoom out. What I got? Look at that. Look at that. So those three major terms got ORed together. Okay? Now, this gets output. No, don't do that. Just get an output marker. Stick it on there. Okay, now, right arrow key, get a piece of wire. Okay, label it F. F. Okay, now, okay, go look for unconnected wires. This X here is acceptable because it doesn't connect anything. Okay, all these don't connect. But if there would be an X, let's say here, actually move these forward here. If there would be an X on here or something, okay, it would be a big problem. Okay, so there's no X's. Uh-oh, mistake here, A primed. That's supposed to be A underscore P. Now hit the save icon on the left corner, top left corner. Okay, I got the AP, I got the A. No, okay, instance 4, instance 5, 6, 7. Instance, and instance 1, 2, 3. Then it goes instance 4, 6, 7, and 5. Okay, then it goes 8, 9, 10, 11 here, 12, 13, 18. Okay, it looks like I got unique instance names. If I get to synthesis and it tells me that I have, or no, when I do file create update, it will tell me if I have an instance name conflict, and I can fix it then and go back to my schematic and fix it, and then regenerate my VHDL code. Okay, so let's look at this. Okay, I got the F circuit. I need the G circuit now. All right. So I'm worn out. So you already know how to draw these now, right? So I'm going to get my G circuit. Oh, it's not there. Okay, let me find it. Okay, so I already have the G circuit down. I'm going to copy and paste it. Control C and paste. Now you guys are going to actually have to do it. All right? Now, so I got that done. Now what? I have to do what? Okay, I've got the schematic. Now, if I would know, actually I do, but let's say you as a student, you don't know how to write the VHDL code from this. The only way you can get the VHDL code is if you make it from a schematic, all right? So, let's go back here. Here it tells you that you can think of this in terms of overall objectives. So to do a simulation, you need two things. A VHDL file which describes your design. Okay? So that is going to be a Lab2 VHD. That's the VHDL code you need. Once you get that VHDL code, you put it in your files list and you synthesize it. Okay, if you get a successful synthesis, then you can ask for a test bench template. Then you can populate the test bench template with process code by copying and pasting it in. All right? And then you have the two things. So people say, well, it's just so many steps. I can't figure it out. No. Think about what your objectives. You are trying to get the VHDL code for design. And you can't write it directly. So what you're going to do is to get the VHDL code for this design, well, okay, is this going to be right or not? Let's just see. This is an optional step. See if it's got any problems that it knows about at this point. Stop sign goes out. We got to wait. What happened? It's done. Okay, what does it say? 0 errors, 0 warnings. Okay, that's good. Now, we could have gone straight to this. File, create update, because this is no good. It cannot simulate from this. It needs the VHDL code from this. The only reason we drew this is because we, actually more you than me, don't know how to write VHDL code. So file, create update, create HDL from current file, and kind you want is VHDL. Okay? So, stop signs up. It's done. 0 errors, 8 warnings. Oh. Okay, double click on it. Okay. Not of instance 1 is not used. Okay, then not of instance 2 is not used. Whoa, boy. Okay, instance 22 not found. Oh, you know what happened? I didn't put a G output on this one. Okay, I thought it was done. So go output, Stick it on there. Okay, then go escape. Escape is here. Now, and then drag it out with the arrow key. Okay, and then label it F. Okay, so if you're not producing the output, a lot of stuff's going to be unused. And then save it. Okay, so now we'll just give it another shot. Yeah, okay. We already created VHDL code and it's wrong because the schematic was wrong, so we got to overwrite it. Oh, I named it F. Oh. Okay, go back here. Name it G. Okay. Now, save. File create update. VHDL, try again. So in the schematic, having the 2 named F is not going to be a problem, but if you burned it to the board that way, it would be. But it's not going to let you do that, okay? Now, we're only down to 2 warnings. Instance 1 and instance 2 not are not used. Okay, do you know why that's happening? Because we don't have all the complements of the variables used in the equation. We don't see every variable being used. So some of these knots are not being used. It's just a warning, okay? And so that's not going to be a problem. So primitive knot of instance 1 is not used. So there is no CP. In this thing, there is no C primed. C never gets primed. A gets primed. D gets primed. I don't think B gets primed either. Don't know why it's not complaining about that. All right, so let me see. Go project, add current file to project. No, don't want PDF. Remove it. Oh no, so I created VHDL file. So I want the VHDL file, so file open. Lab2 VHD, that's the VHDL code from the schematic, which is what I really need, not this. Okay, so this is schematic. So your entity name is Lab2 that I got from the file name. That matches the lab name, which is Lab2. So this is going to be top level entity. It's going to make a test bench for this entity. Now you see it really stumbles at trying to figure out what the equations are. Now, later on, you'll learn how to write your own equations between the beginning and end. And you'll get something like this. Okay, you see, where is it? Now, this is not this term's work. This is a different equation you had in the previous term. So you can take that equation, copy and paste it, and use the VHDL operators, which are not, and, or. Now, in VHDL, it does not assume precedence, so and expressions have to be bracketed. It does not assume precedence of operations. Okay, so this is, if you knew what you're doing, you could have a nice, simple equation. All right? Now, the software cannot figure out the equation in one shot. It has to try to do it piece by piece. Okay, good. So, what are we doing now? We got that done. So what we need now is a test bench. And you can't get the test bench until you synthesize this. I don't believe we synthesized it yet. We just created it from the schematic. and it knows some error. So we want the test bench next, but we can't go directly to the test bench because it won't know how to make the test bench template until this code is partially compiled, because it has to make a test bench custom made for this code. Won't know how to do that unless the test bench is partially compiled. So hover over here. What's it say? Start analysis and synthesis. What's this? Full compile. What's this? Analysis elaboration. No, you want synthesis. So synthesize this code. The reason if we go direct to the test bench, it will do the test bench, but then we'll say either error or warning, you did not synthesize your code. Then you have to go back and synthesize. Waiting for the stop sign to go out. Now, somewhere up here, you see where it says flow summary? You will get errors up here. These don't matter. Only the ones down here. Only the errors and warnings down at the message box below ever matter. Waiting for the stop sign to go out. Okay, you see this? Using design file lab2VHD, which is not specified as a design file. You know why that happened? It happened because I failed to do this. Project, add current file to project. It would have worked anyway because there's no other possibility for top level except this, because you don't only have one file. Okay? I don't know. Maybe, maybe not. All right, so do it again. Okay, now if you had lab2BDF here also, you would get a duplicate file name. Let me do that. Let me do it. Synthesize. Watch what happens. Come on. Boy, it's taking a long time. Maybe pause the video, I don't know. There it is. Can't compile duplicate declarations of Entity Lab 2 into library work. So you got two different versions for Lab 2 that conflict with each other. Now, I get this all the time. Okay, over and over and over again, the students will point this out to me and they say, I don't know what this means, can't compile duplicate declarations of Lab 2. Now you know what it means. Okay, it says you got Lab2BDF, you got Lab2VHD. Which one do you want to synthesize? Okay, you got duplicate. So you really can't use the BDF. So click on the BDF, right click, remove file from project. Okay, so now I can try it over again. Hover over, it says synthesize, and synthesize. Stop sign is up for a long time. So my whole objective was to get this VHDL code. The schematic it can't use. The schematic was drawn just to be able to create the VHDL code for it. And then before you can get the test bench, you got to partially synthesize that code, because it won't know how to make the test bench otherwise. So successful, 0 errors, 0 warnings. Okay, so watch. Let's look at this rather. Now, I'm ready to do a test bench. So I can look up what the command is for getting a test bench. Test bench template. Processing start. Test bench template writer. Okay, what does it say down below? Look at the message window down below. It says Quartus Prime EDA Netlist Writer. Okay, the netlist is that test bench template. That's called a netlist. Anything that describes how things are connected together in a language is called a netlist. Okay, so your netlist writer was successful, 0 errors, 0 warnings. So that means there's a netlist somewhere that was created. Let me find it. File open. Now, it's going to be under simulation. It's going to be under model sim. No, it doesn't show up. So I got to change my file filter down here to all files. Now it shows up. It says VHT. Now, you see where it says add file to current project? You can do that. Check it. Okay, so now I got the 2 files I need to do my simulation. Okay, I got a test bench. No, actually I don't. The test bench is not complete. How do I complete the test bench? Well, I got to download my PowerPoint. Okay, and then I got to get this between the beginning and wait. Control C to copy it. Okay, then I got to go in the very last process of my test bench. What's a process? Process begins with a label and a process keyword, and keywords are in blue. And it ends with an end process statement. And the name always is optional. So I got to put it here. Now, this comment I really don't need. I can erase it. And I can do Control V here. So now I have filled in the process for my test bench. I have a full-blown test bench, not just a template. And I can save it here. See? So now I can say I got design code for the design, and I got test bench code. So those are the 2 things I need to do my simulation. All right? All right, so simulations under tools, run simulation tool, RTL simulation. Now, you should be able to start looking this up because I got summary steps documents and I got summary steps in Lab 1 report right up. So you should be able to do this. Okay, now you see down here at the bottom, it's got 7K or something. Now, it turned into an M. Once that happens, you can maximize it. Okay? All right, now, you're going to need a simulation project. So file. No, actually, got to wait a while. Okay, actually, you got to go simulate and the current simulation. If you go too soon, nothing's going to work. You got to wait a while and make sure any simulation that is running is ended. Then go File, New, Project. Name it Lab 1. Okay, now you got to add your existing files. So under Model Sim, there's your test bench, VHT. No, I screwed up. How did I screw up? I gotta quit. I screwed up. You know where I screwed up? I didn't tell it which one is the test bench. Okay, so I gotta go Assignments, Settings. Settings for simulation. Now, this business Writer settings, it's already done. It's already done for you in the zip. So don't worry about that. Now, radio button, compile test bench. Browse for a test bench, so new one. Okay, give it a name. Lab 1. And then, okay. Oh, okay. So use the browser icon to find it under simulation Wallace. The Lab2 VHD T, not the backup. The VHT, that one. Okay, so that's it. The VHT is a test bench. Add that. And then, okay, see what happens. So it wants to add this test bench. Okay, so okay. Okay, so it knows that Lab2 VHT is the test bench. So when you go into the simulator, you'll see that test bench to select in the work folder. Otherwise, it won't be there unless you do this. So now you can go Tools, Simulation. It seems like I have to wait forever. Oh, Mollisum's already there. There it is. Okay, now watch. You see in work, there's a Lab2 VHD test. That would not be there unless I did settings for simulation. All right. Now, I have to create a new project. But first, I got to close any existing simulation. Then File, New Project. And it's going to be called Lab 1. Okay. Now, add existing file. Browse for it. So take this VHT test bench code, add it. Go back again, add existing file, browse for it. Go now, use up folder. This Lab2 VHD, give it that. Yeah, so there's your test bench. There's your VHDL code. Let's just look at this test bench. Yeah, it's good. Look at this VHDL code. Yeah, it's good. Okay, now go compile. Compile all. Okay, down here in the message box. 2 compiles with no failures or errors. Okay, so now you are ready to simulate. As long as you got no errors. Now, what if you had errors? You want to see it with errors? So watch what I do. I'm going to make an error. I'm going to make an error by, I got 2 weights, but it won't cause any problem. Okay, I'm going to take that semicolon off and then save it here. And then I'm going to do compile all. Now, when I go down here, it says it failed in the VHT with 2 errors. So I double click that. Okay. And I click this, double click this. See if it takes me to the error. Yeah, it takes me to the error. So the error happened here because this semicolon was missing. So I fix it and I save it with the save icon near the top left. And then I go compile all. 2 compiles, no failures. So now I'm going to go ahead and do my simulate. Start simulation. Now, expand work folder. Now you see Lab2VH test. The reason it's there is because I declared it under assignment settings in Quartus. I declared that as my test bench. So when I come in here, it knows. Now my resolution got to be NS for nanoseconds. Okay. Now you see what it did. Let me get rid of this. Okay, so there's only these variables, A, B, C, D, F, and G. So pick one of them. See, I had to make the window bigger. You can find your windows here. If you lose your wave window, you can find it there. Okay, so select one of them. Then go add 2 wave signals in region. So that means all the other ones that are in the region where I selected, these names get added to the waveform now, see? So now I have to set my total time to 800 nanoseconds. No. Well, I got it nanoseconds now. So do 800 nanoseconds, okay? And then do restart. Okay, and then do run it. Now, I'm not going to run it because you are just going to copy and paste from here. Okay? Instead of doing it yourself. So, when you get this far, you run it. And you check if it's right. And then you're going to have a lot of head scratching to do if it's wrong. Okay? But at every step of the way, at every step of the way, make sure that you check your errors and warnings and fix them. Okay? At every step of the way. Then you will not have problems. All right? Now, what's going on now is summer term. This summer is only 7 weeks. So what that means is we don't have all 14 weeks we normally have. But it doesn't matter because in the summer, a student typically takes only 1 course or 2. Doesn't have 5 or 6. Okay? So can have a more intensive workload on one particular course. So what this means is we have to have 2 labs per week. So this week you got to get Lab 1 and Lab 2 done. Okay, and the due dates you're going to use are what I put in the campus assignment folders. And I haven't decided on a due date for Lab 2. Professor Shahood is thinking in terms of something like May 12th for Lab 2. All right, so there's going to be 2 labs a week. Now, and Professor Shahood said there's also going to be lab quizzes. But the lab quizzes will not start. I believe they will not start until next week. Now, what you need to do is always check your announcements in Canvas to make sure you're up to date with what's going on in the course. Okay? Because then you will know whether it's a quiz or not, or anything new happening or not. So once you got what? Once you got your schematic, okay, we have to find it. Okay, either click on it here or file open. Find it, okay? Find it. And then what? Snipping tool to get it for your lab report. And then here, when you run these waveforms, use snipping tool. Now this Let's undock it. Okay, we lost it. So you can go down here, see there's two panes. Or you can go here, window, and get wave. Okay, and then you can adjust this up and down so that the number of nanoseconds is in the correct place. All right? And then you can redock when you're done. So you have to get that snipped. Now, normally I would ask if there's any questions, but there's nobody here to ask questions. So I guess we are done.